Dear GATE aspirants, welcome to Veda GATE Academy, your one and only destination for GATE and IAS coaching. If you remember, in the last class, we have seen the transformations of the independent variable and we have seen how we can perform a transformation involving shifting as well as scaling. We have two methods we discussed. They are first shift then scale and first scale then shift by taking alpha as common. Before going to the problem, let me give you a quick recap on the first shift then scale and first scale then shift. After that, we'll solve some problems. Okay, right. So what are the methods we have? If I give you the summary kind of thing, let me write summary. Summary for what? If you have shifting as well as scaling in one transformation, right? I can give like this. Observe here. Listen carefully. If the given transformation is in the form of x of alpha t plus beta, which involves shifting as well as scaling, the first method what we discussed was first shift then scale. What is the path? See, if the given transformation is in this form, start with x of t first in this method. Start with x of t. First shift the signal. Observe the shifting factor. What is shifting factor? Beta. Go to x of t plus beta. You consider this shifted signal to be y of t, some y of t. Now, you have to scale this y of t by alpha to get x of alpha t plus beta. This is the method. First method, first shift then scale. What is the other method? First scale then shift. First scale then shift. So, in this method, if the given transformation is in the form of x of alpha t plus beta, one point I told you to remember. What is that? You have to take this alpha as common. Taking the alpha as common is mandatory. So, I can write this as x of alpha times t plus beta by alpha. Now, follow the path. First scale. So, what is scaling factor we have? Alpha. So, go to x of alpha t. After that, here you may have plus or you may have minus also. If you have plus, simply advance. If you have minus, you delay by beta by alpha. These are the two methods which we are going to follow. Now, we'll do one thing. Let's solve one problem, right? So, I'm taking one problem. The problem is like this. We are given a continuous time signal like this. This is the continuous time signal. Right. From this signal, he is asking us to calculate some quantities. They are x of t minus 1, x of t plus 1. Third one is x of minus t. Fourth one is x of minus t minus 1. Fifth one is x of minus t plus 1. Sixth one is x of 3 by 2t. Seventh one, last one is x of 3 by 2t plus 1. There is no hurry. We'll solve one by one. Right? Now, look at the problem. Look at the given signal x of t and the required things. One by one we'll solve. Let's start with the first one. X of t minus 1. Now, first one, x of t minus 1. By looking at this transformation, what comes to your mind? Well, it is nothing but shifting, no? So shifting means compare with the standard shift I told you. This is in the form of x of t minus t naught, where the value of t naught is how much? 1. Time shifting operation, here t naught is positive means from our discussion, the resulting signal will be delayed version or advanced version? Delayed version. Delay means right shift or left shift? Right shift. So simply shift right the given signal x of t by 1 unit. Shift right the given signal x of t by 1 unit. This is x of t minus 1. Right? First one is completed successfully. Now look at the second one. Second one is what? X of t plus 1. Again, by looking at this transformation, what comes to your mind? Time shifting operation again. So compare with the standard shift. What is the standard shift? This is in the form of x of t minus t naught, where the value of t naught is how much? Minus 1. Positive or negative here, t naught value? Negative. Time shifting operation, t naught negative means what? As per our discussion, the resulting signal must be an advanced version. Advanced version means right shift or left shift? Advanced version means left shift. By how many units? 1 unit. So simply shift left this signal by 1 unit. I got this kind of signal, x of t plus 1. So put a tick mark to this one. So second one is also completed. Now let's look at the third one. Third one is what? X of minus t. Okay, fine. Third one is x of minus t. See, x of minus t. First of all, whenever you are given a problem, you must make the preliminary analysis. X of minus t is what? Time reverse version. Time reverse version means mirror image along vertical axis. If you have amplitude reversal, mirror image along horizontal axis. So simply take the mirror image along vertical axis for this given signal. So given signal, if you take the mirror image along vertical axis or fold the signal along vertical axis. This is x of minus t, right? Observe here. This is the signal. Simply I folded the signal along the vertical axis, right? So now if I ask you what is minus x of minus t, suppose if I ask you what could be minus x of minus t, to this time reverse version, take the mirror image along horizontal axis. Take the mirror image along horizontal axis. How does that look like? That looks like something like this, isn't it? Minus two, minus x of minus t. Fine, this is also completed. So put a tick mark to x of minus t also. Now, fourth one, x of minus t minus 1. Now the actual problem starts, because delay, advance, reversal already we have seen, we know. Now actual problem starts from 4. So what is the fourth one? X of minus t minus 1. Right. Fourth one, x of minus t minus 1. If you observe, my dear students, this is in the form of, can I say that this is in the form of x of alpha t plus beta, which involves shifting as well as scaling? Yes, it is in the form of x of alpha t plus beta. So how many methods we have? Just now we have seen, no, first shift then scale we can go, or first scale then shift by taking alpha as common. You can go. So let's go with first shift then scale. First shift then scale. What happens if I go by first shift then scale? X of t is there with me. First shift the signal. Shift the signal. What is shifting factor? Minus 1. So go to x of t minus 1. And what I said? Call this as y of t. I said no. Now scale this y of t by the scaling factor. Scaling factor is minus 1. And in the previous discussions we have seen that scaling by minus 1 is nothing but reversal. Scaling by minus 1 is equivalent to taking the time reversal only. So simply take the reversal of y of t to get x of minus t minus 1. Now if you try to plot the resulting signal, now x of t is there with you. This is x of t, isn't it? X of t minus 1. X of t minus 1 means what? Delayed version, right shifted version. Right shifted version like this. This is x of t minus 1 and we are going to call this as y of t. No, this is our y of t. Now what we have to do, you have to scale this y of t by minus 1, means nothing but taking the reversal. So take the reversal. Reversal means what? Mirror image along vertical axis or folding the signal along vertical axis. Now what happens if I take the reversal? So if I take the reversal for this one, if I take the reversal, it will come something like this. This is what is your x of minus t minus 1. Hope you also got the same answer. Now one more method I'll adopt. What is that? First scale then shift. For the same problem, if I go with first scale then shift, what will happen? But what is the requirement for first scale then shift? You have to take alpha as common, the scaling factor as common, right? So x of minus t minus 1 can be written as x of, take alpha is common, alpha is minus 1. So I can write this t plus 1. Now the path, x of t is there with you. First scale, scaling by minus 1 is nothing but a reversal, right? Now after that plus is there, plus means advance by how many units? 1 unit. Now let's draw. X of t is there with you, the original signal. X of minus t means time reverse version, mirror image along vertical axis, right? Now advance means right shift or left shift? Left shift. By how many units? 1 unit. So you simply advance this, shift left by 1 unit, so that you are going to get this equation. This is what is your x of minus t minus 1. Compare with the previous result, you got the same answer. You will get the same answer, right? So first shift then scale, first scale then shift by taking alpha as common, completed. So fourth one completed. Let's attack the fifth one with the two methods. Those who are not followed the fourth one, you can follow from the fifth, no issues. Right, fifth one, x of minus t plus 1. First shift then scale. First shift then scale. Path, x of t there with you. First shift the signal, go to x of t plus 1, call this as y of t, scale this y of t by minus 1 to get x of minus t plus 1. So x of t is there with you. This is what is your x of t. X of t plus 1. X of t plus 1 means advanced version, left shift. Now this is y of t, now I am calling. Now for this y of t, what I have to do? I have to calculate the reversal, y of minus t. So take the mirror image along vertical axis or fold the signal along vertical axis. This is what is your x of minus t plus 1. Now let's try to get the same answer using first scale then shift. First scale then shift. So what is the requirement for first scale then shift? You have to take alpha as common, no? Minus of t minus 1. What is the path? X of t is there with you. Go to x of minus t first scale. After that minus is there. Minus means delay. By how many units? 1 unit. Okay. Now observe. X of t is there with you. The original signal. Right? X of minus t. Fold. Now delay means right shift. By how many units? 1 unit. Observe, we got the same answer. You will get the same answer. In this way, we can solve the fifth one. So we are done with 1, 2, 3, 4. Fifth one is also completed. Sixth and seventh are left. Sixth and seventh are left now. So let's attack sixth and seventh. What is the sixth one? X of 3 by 2. First of all, make some preliminary analysis. What operation is performed? Scaling is performed. How do you know that it is scaling? Are multiplying independent variable by a constant is scaling only, right? So time scaling is done. This is in the form of x of alpha t, where the value of alpha is how much? 3 by 2. So alpha value is greater than 1. If alpha value is greater than 1, if the scaling factor happens to be greater than 1, the resulting signal must be a compressed version of the original signal, right? How to get the compressed version or expanded version? Divide each point on the horizontal axis with the scaling factor I told you. So here, what is the signal? This is the signal x of t. This is the signal xt. Now, in order to get either the compressed version or expanded version, what we have to do? The easiest method is divide each point on the horizontal axis with the scaling factor. What is the scaling factor in our case? It is simply 3 by 2. So, what will happen? Observe here. 0 by 3 by 2 is 0, 1 by 3 by 2 is 2 by 3, 2 by 3, and 2 by 3 by 2 is 4 by 3, 4 by 3. This is what is your compressed version. The width got reduced, compressed version, right? Now 6th one is also completed. We are left with the only 7th one. What is that? X of 3 by 2t plus 1. X of 3 by 2t plus 1. So this is in the form of x of alpha t plus beta. So you can go with first shift then scale and first scale then shift. So if I go with first shift then scale, which I called as method 1. Method 1 is first shift then scale. What is the path? So here already x of t is there with you. Go to x of t plus 1, shifting, call this as y of t. Scale this y of t by how many units? 3 by 2 units. To get x of 3 by 2t plus 1. Right? Now, let's draw. X of t is there with you. X of t. X of t plus 1. X of t plus 1 is advanced version. Left shifted version. Minus 1, 0, 1. Now, this is your y of t. Now, you have to scale this y of t by how many units? 3 by 2 units. 3 by 2. So, divide each point on the horizontal axis with the scaling factor. So, this becomes minus 2 by 3, 0, 2 by 3. This is what you are going to get. First shift, then scale. Now, if I go with the second method, that is first scale, then shift, by taking alpha as common, we'll see whether we are going to get the same answer or not. We must get. Let's verify. Method 2, M2. X of, what is asking? 3 by 2t plus 1, no? Now, if I take alpha as common, I can write this as x of 3 by 2 times t plus 2 by 3. What is the path? First scale. X of t is there with us. Go to x of 3 by 2t. Plus is there. Plus means advance by how many units? 2 by 3. X of t is there with us. X of 3 by 2t. X of 3 by 2t means ready-made available, no? 6th one. Compressed version. 0, 2 by 3, 4 by 3. This is x of 3 by 2t. And you have to advance this by 2 by 3. Advance means right shift or left shift? Left shift. So shift left. What is the advancement of 0 by 2 by 3? Minus 2 by 3. What is the advancement of 2 by 3 by 2 by 3? 0. 4 by 3 by 2 by 3? 2 by 3. In this way, you are going to get the answer. Let's verify whether you got the same answer in the previous case. Yes, we got the same answer. So, the methods what we discussed are very powerful method. First shift then scale and first scale then shift by taking alpha as common. See, one question naturally comes to many students is that, suppose if you have a signal like this, suppose I am taking the signal like this, the same signal in the previous problem I am taking. If I am having a signal like this, if they ask find x of minus 3 by 2t, if they ask like this, if they ask x of minus 3 by 2t, means reversal is there, scaling is also there. Reversal is there, scaling is also there. Now, in such cases, how you are going to perform? You may get one doubt that, sir, first which operation you have to follow, either reversal or scaling or both at a time. So, I'll say that you can follow any method. Look here. Suppose if I follow x of t is there with us, I'll follow like this. X of t is there with me. What is the first operation you suggest? Scaling. Okay. X of 3 by 2t. First scaling, then reversal. Okay. Now, what is the other method? We can have x of t. First reversal, then scale. Or directly applying both, directly scaling the given signal by minus 3 by 2. These kind of doubts generally we get. Now, let's see what is that we are going to get here. X of t is there with me. X of t is there with me. X of 3 by 2t. X of first scaling. 3 by 2t means already we have seen. Divide each point on the horizontal axis with the scaling factor. 2 by 3. 4 by 3. After this, take the reversal. Reversal means mirroring along vertical axis. 0. Minus 2 by 3. Minus 4 by 3. This is what we are going to get. Right? Now, what happens if I follow the next one? X of t is there with us, take reversal and then scale. So, what I am saying is that you must get the same answer. Always try to experiment. With experimenting only, our subject will improve. X of minus t. X of minus t means reversal. Now, you scale this by 3 by 2. So, what happens if I scale this by 3 by 2? Divide each point on the horizontal axis with the scaling factor. So, this becomes minus 4 by 3, minus 2 by 3. See. Observe here. You got the same answer. So, you can follow anything. So, if you want to go with the scaling first, yes. If you want to go with the reversal first, nobody is going to stop. So, any method you can follow. So, both will yield the same answer. Or directly also you can say, what I say is, directly also you can get by scaling with minus 3 by 2. Divide each point on the horizontal axis with the scaling factor. If you consider the scaling factor to be minus 3 by 2, then also you will get the same answer. For that, observe here. What will happen? 0 by minus 3 by 2. 0 by minus 3 by 2 is 0. Next, 1 by minus 3 by 2. Minus 2 by 3. 2 by minus 3 by 2. Minus 4 by 3. Same answer we get. Observe here. In the 3 cases. Now, similar kind of doubt we are going to get in discrete also. Discrete, okay. These are very, very important questions what we are discussing. Suppose if you are given a discrete time sequence like this: 3, 4, 5, 4, 3 with arrow placed at 5. So, and you are asked to get what is x of 3 by 2 n. 3 by 2 n. Now here decimation is there, interpolation is also there. If I consider x of 3n only, it corresponds to decimation. If I consider x of n by 2, it corresponds to interpolation. Both are there. Both are there means here also you can follow any method. You can follow any method as you wish. See what I am going to do is, x of n is there with me. First decimate. First decimate means x of 3n. Then interpolate. To the resulting signal you interpolate. Default interpolation is what? 0 interpolation. Unless and otherwise specified, you must go with 0 interpolation. Means missing samples are replaced with zeros. Now x of n is there with us. 3, 4, 5, 4, 3. X of n is right. 3, 4, 5, 4, 3. Right? I'm sorry. X of 3n. Decimation, what is the short method I told you? So first of all, observe the scaling factor and you keep the sample value at n is equal to 0 as it is. To the right and left side of arrow, skip alpha minus 1 number of samples. Alpha minus 1. Alpha is 3 here. Alpha minus 1 means 2 samples. So skip. Right side, left side order, 2 samples. If you are skipping only, we are left with this one. Right? Now, interpolation. Interpolation by what factor? By 2. So if your interpolating factor is 2 means between the consecutive samples, how many zeros will come? 1 0 will come, but I have only one sample here. One sample. So where you are going to put the other samples? So it doesn't make any sense. So if you see here, you can put some zeros also. Nothing will happen in discrete. If something is missing, here you can replace the missing sample with zeros. I can consider like this. Or I can, if I remove this zeros also, no issues. Right? Now, this is what I am going to get if I decimate first, interpolate next. Now, reverse if I do, x of n is there with me. First of all, interpolate n by 2, then decimate. Resulting signal you decimate. 3n by 2. That's what is asking now. So x of 3n by 2. So what is your x of n? 3, 4, 5, 4, 2. This is your signal. X of n. Now x of n by 2. So here interpolation is done. So interpolation and the denominator is here 2 means between the consecutive samples in the original signal, how many zeros will come? 2 minus 1. 1 0 will come. So this will become 3 0, 4 0, 5 0, 4 0, 3 with arrow placed at 5. Now I have to decimate this by 3. Decimate by 3 means to the right and left side of arrow, skip alpha minus 1 number of samples. Here alpha is 3, alpha minus 1 means 2. So if I skip, what will happen? Okay. This I have to skip, this I have to skip, this I have to consider. Again, after that, again 2 samples you discard. Right? Left side also same. Discard this one, include this one, 0. Again, discard. If you have any samples left also, you have to discard that one and include the next one. So here, if I try to write, so 0, 5, 0. Same thing. Same thing. Or you can directly go with x of 3 by 2 also. So you try to scale this by x of 3 by 2, then also you get the same answer. Right? So either way you can follow. Right? You can first decimate, then interpolate. First interpolate, then decimate, or directly to the given signal, you can scale by 3 by 2. You will get the same answer. Right? So this is about the transformations of the independent variable examples. After this, let me take the next part, which is nothing but how to find the area under the signal. Area under the signal. How to find out the area under the signal? Very, very important topic. Right? See, here the signals what we are going to consider or what we are going to study, they may fall in two categories. They may be a finite duration, they may fall in finite duration category or infinite duration category. See, finite duration signals means they will exist only of finite duration. Infinite duration signals means they exist from 0 to infinite or 0 to minus infinite or minus infinite to plus infinite. So, signals exist only for a particular duration are known as finite duration signals, whereas signals which exist for infinite duration are known as infinite duration signals. So, if you are given a continuous time signal, here I'll write like this, continuous, here I'll take discrete. So, I may have a finite duration signal, I may have an infinite duration signal. Finite duration, let me write clearly. Infinite duration signal. Right? Now, how to find out the area? Say, you have a continuous time signal which is existing from T1 to T2. T1 to instant T1 to T2. Then, its area is nothing but integral T1 to T2. Always remember, integration in the case of continuous time signal represents area. Integral T1 to T2 x of t dt. Finite duration signal. Infinite duration signal means I'm assuming that my signal is existing from minus infinite to plus infinite. So, infinite duration signal, area, integration x of t dt. Right? Now, discrete time. So, here discrete time, let me write in clear, otherwise you will get confused. Continuous time, discrete time. Right. Discrete time, finite duration. Area is given by summation. Always remember, integration for continuous time signal represents area, whereas summation for discrete time signal represents area. So, this is from some n1 to n2 x of n. X of n. Then what about infinite duration discrete time signal? So, n varying from minus infinite to plus infinite x of n. See, apart from this area, we have absolute area concept also, but we will be discussing later. For the time being, we are concerned only with the area under the signal. How to find out the area? See, the signal may be a finite duration signal or infinite duration signal. Finite duration signal is integral T1 to T2, means the limits where or the range in which the signal is lying. Integral T1 to T2 x of t dt. If it is infinite duration signal, assuming that the signal is existing from minus infinite to plus infinite, minus infinite to plus infinite x of t dt. Very simple. So, area, you can represent area. A is equal to. So, discrete time finite duration signal area and discrete time infinite duration signal area. Now, we'll do one thing. Let's test whether what happens to this area with our transformations of the independent variable, particularly time shifting, time reversal, time scaling. Right? After that, we can make conclusions also. So, let's switch to that topic. Now, time shifting. Time shifting. What happens to the area of the signal with the time shifting? Let's verify. This is a signal x of t, from which I want to get x of t minus 1 and x of t plus 1. X of t minus 1 is what? Delayed version. Delayed version means like this. x of t plus 1, advanced version, left shift. X of t. Now let's find out the area. Area is nothing but this. First of all, this is a finite duration signal. Finite duration signal. Now, if I want to calculate the area, so this is in the form of a rectangle. No, width into height gives the area. This area. So here area is width. Width is how many units? 1 unit. Height is 1 unit. So area is 1. Area is 1. Now here what is area? Width 1 unit. Height is also 1 unit. Area is 1. Means with the delay or with shifting here, with the delay area is not changed. Area is not changed. Now similarly observe here. Width 1 unit. Height is also 1 unit. So area is 1. This area. Or if you integrate also, you get the same answer. So for finite duration signal, with shifting, there is no change in the area. For finite duration signal, with shifting, there is no change in the area, and the same thing holds good for infinite duration signals also. Infinite duration signals also, or you can say that area under the signal x of t. Here x of t may be a finite duration signal or infinite duration signal. Finite duration signal or infinite duration signal. Area under signal x of t does not change with the time shifting. Does not change with the time shifting. Can I say this? Does not change with time shifting. Very, very important point. With time shifting, there is no change in the area under the signal. Then what about time reversal? Let's verify. Experiment and get the result. Time reversal. Time reversal. So x of t is there with us like this. 1 to 2. This is x of t. What could be x of minus t? X of minus t is the time reverse version, mirroring it along vertical axis or folding the signal along vertical axis. Right? Now, let's see what happens to area. First of all, before applying the transformation, what is the area under the signal? This is the area under the signal. What is width? Width is 1 unit, height is also 1 unit, so area is 1. Or if I have any doubt, apply integral 1 to 2, 1 dt. This is nothing but t between limits of 1 to 2, which is nothing but 1. Right? Now here what happened? Width is 1 unit, height is also 1 unit. So area must be 1. Area must be 1. Or if you have any doubt, integral minus 2 to minus 1. Integration is area only, right? 1 dt. Or this is nothing but t between limits of minus 2 to minus 1. Or this is 1. So area under, and let me tell you, the same thing holds good for infinite duration signals also. I haven't taken any infinite duration signal, but it happens the same, because we haven't seen the infinite duration signal like step signal, signum, ramp signals, no. So I'm giving the statement. So area under the signal x of t or x of n also. The discrete also, area will not change. Anyway, we'll see area under signal x of t does not change with time reversal. Time reversal. Discrete also, let us verify. Otherwise, you'll be having doubt. I don't have any space here. Okay, no problem. No problem. Here I'll take. Look here. X of n is equal to. What a signal we are going to take? Let's take our famous signal. 3, 4, 5, 4, 3 with an arrow placed at 5. So we'll do one thing. Let's calculate x of n minus 1 and x of n plus 1, and let's calculate area under x of n minus 1 and x of n plus 1. But before which, we have to calculate what is the area under the signal x of n. Here, look here. Arrow indicates sample value at n is equal to 0. Sample value at 1, sample value at 2, sample value at minus 1, sample value at minus 2. What is the area? Area is equal to summation for a finite duration signal. N is equal to n1 to n2 x of n. This is the expression. Clear? Now, this is nothing but summation. N varying from, the signal is existing from what value to what value, my dear students? Minus 2 to 2. Very simple calculations. X of n. So, what this will result in? So, this is nothing but x of minus 2 plus x of minus 1 plus x of 0 plus x of 1 plus x of 2. So, add all the sample values. So, area under the discrete time signal is nothing but adding all the sample values. Adding all the sample values, remember. So, what will happen if I add 3 plus 4, 7, 7 plus 5, 12, 12 plus 4, 16, 19. Isn't it? 19 only. 19. Right? X of n minus 1. Now, area under x of n minus 1 I want. So, area under x of n minus 1. First of all, can you get x of n minus 1? Can you get x of n minus 1 without drawing the signal? I told you, no. If you are delaying the signal by 1 unit, if you are delaying the signal by 1 unit means arrow moves to the left by 1 unit. So, 3, 4, 5, 4, 3 with the arrow placed at 4. So, this is the sample value at n is equal to 0. This is minus 1. This is 1, 2, 3. So, area becomes what? Area under x of n minus 1 I have written. My dear students, observe here. Summation. The signal is existing from what value to what value? Minus 1 to 3. X of n. So, if I call this y of x of n minus 1 as some y of n, better to call it as y of n. So, this is y of n. What will happen? Y of minus 1 plus y of 0 plus y of 1 plus y of 2 plus y of 3. Right? So, add all the sample values. Add all the sample values. You will get the same 19. 19. In the same way, you will get for this one also the same area under. You will get the same value for the area for the signal x of n plus 1. So, area under continuous time signal or discrete time signal does not change with shifting. That is generalization we can give. Here I have written something now. Area under x of t does not change with shifting. Area under x of t or x of n. Area under x of t, either continuous time signal or discrete time signal, does not change with time shifting. Then what about time reversal? Time reversal also the same thing holds good. If you want, you can verify. So, area under the signal x of t or x of n does not change with the time reversal. Time reversal also it will not change. Now let's see what happens with the scaling. So this is example we are seeing. So scaling, what happens to this area? First of all, time scaling operation. Time scaling operation. See, I'm taking a signal like this, which is defined from 2 to 4 with a value of 1. This is x of t. Right? Let's get x of 2t and x of t by 2. How to get x of 2t? Divide each point on the horizontal axis with the scaling factor. 1 to 2. X of t by 2. 4 to 8. With a value of 1. Now, what is the area under the original signal x of t? The signal x of t. What is the area? Here, area is width into height. So 2 units, 2 square units, right? Here you can write units also, 2 square units. Here area under x of 2t. This area is 1. Width is 1, height is 1. 1 square units. Here area. Four units. So area is not same if you are going to scale the signal, right? So the resultant signals will have different areas, and you can relate also. You can relate also. How you are going to relate? I can say like this. If x of t is a signal which is having an area A, then x of alpha t. Suppose if you are going to scale, the signal, x of alpha t will have the area as A by mod alpha. A by mod alpha. Let's verify. Means if x of t has an area 2, so as per our discussion, x of 2t must have an area 2 by 2, which is nothing but 1. Verified? Verified. X of t by 2. X of t by 2, what will happen? Must have an area of 2 by 1 by 2, which is nothing but 4. Let's verify. Yes, verified. So you can say like this, right? If I take the reversal, look here, if alpha value happens to be 1, it becomes a reversal, no? So reversal, mod of minus 1 is 1, so there will be no change in the area. So remember, if the signal x of t is having the area A, then x of alpha t will have the area A by mod alpha. This is for continuous time. Continuous time. Now what about discrete time? So let's see the discrete time signal. Time scaling for discrete area calculations we are seeing. For that, let's proceed with an example. So x of n is 3, 4, 5, 4, 3. This is the signal x of n. Right. First of all, what is the area? Area under x of n. Area is nothing but discrete time signal set of sample values. Sorry, not set of sample values. Adding all the sample values. Right? What happens? 19. Area under signal x of n. What happens if I calculate x of 2n and x of n by 2? X of n by 2. So x of 2n means what will happen? X of 2n, to the right and left side of this arrow, skip alpha minus 1 number of samples. So it will be 3, 5, 3. Area 11. It changes. It changes, but it will not have any relationship with this one. In discrete, area will change with the decimation interpolation, but it will not have any relation as we are having in continuous case. Now here what will happen? Sorry, it will not change here. 3 0 4 0. Between the consecutive samples, 1 0 is inserted now. If you are interpreting by a factor called 2, between the consecutive samples, 1 0 is inserted if you are going for 0 interpolation. So what is the area? Area means add all the sample values. So it is nothing but 19. Now what can you write here? What can you write? See, area under discrete time signal, x of n, what will happen? Area under the discrete time signal x of n changes with the decimation, changes with the decimation. Decimation means if the scaling factor is greater than 1, changes with decimation, but not change with interpolation, and this is restriction. There is a restriction and does not change with interpolation if 0 interpolation is taken. If you are going to take step interpolation or linear interpolation, definitely area will change. But default interpolation is 0 interpolation. No, with 0 interpolation, area is not going to change, but not change with interpolation if 0 interpolation is considered. If 0 interpolation is considered. Right, this is an important point. Right, so this is about the area concept with respect to the continuous time and discrete time transformations of the independent variable. So we are seeing like this. Let me revise one more time. See, area means for a continuous time signal integral, for a continuous time finite duration signal integral t1 to t2 x of t dt. For a discrete time finite duration signal integral n1 to n2 x of n. If you have infinite duration signal, so limits will become minus infinite to plus infinite. Here also minus infinite to plus infinite, and we are looking at the transformations of the independent variable. Suppose if you look at the first transformation of the independent variable, time shifting operation. So for continuous time finite duration signal, area does not change with time shifting, and the same thing holds for infinite duration also. And for discrete also, area will not change. How we are going to find out the area under discrete? Add all the sample values. So here what I have written, area under the signal x of t, continuous time, or x of n, does not change with time shifting. So the same thing holds for time reversal also. Area under the signal x of t or x of n does not change with time reversal. Either for continuous time or discrete time. If I go for this is an example proof, no, time scaling operation. What happened? For continuous time, area will change with if the signal is compressed or expanded, area will change. There is a generalized relation also. If x of t is a signal having the area A, then x of alpha t will have the signal A. If alpha t will have the area is A by mod alpha. For finite duration and infinite duration also the same thing holds good. Here, time scaling operation for discrete. So what we have seen, area under discrete time signal x of n. Changes with the decimation. Definitely changes with decimation, but not change with interpolation if 0 interpolation is considered. Instead of 0 interpolation, if you are going to take step interpolation or linear interpolation, what we have seen in the previous lectures, area will change. Alright. Now if I take a continuous time signal in particular, okay, x of t I am having, a signal, finite duration signal, infinite duration signal. Say this area is here. Its area is here. Now, t plus or minus beta. If you delay or advance by beta, does area change? No. Area will not change. Suppose if I take x of alpha t plus or minus beta, if I scale, what will happen? So area does not change with shifting, but area changes with scaling. A by mod alpha. A by mod alpha. Suppose if I amplitude scale b x of alpha t plus beta, b x of alpha t plus beta, if you're amplitude scaling, definitely that will have effect on the area also. So this is nothing but AB by mod alpha. AB by mod alpha. So similar kind of analysis you can make for discrete time also. Right? Now, after this is completed, let me tell you one more important point, which is nothing but the width of a signal. Width of a signal. So I am going to take continuous and discrete and how to calculate the width. Say I have two finite duration signals. One is continuous time. This is a continuous time finite duration signal x of t, and I am going to take a discrete time finite duration signal I am going to take here. Say this is existing from, one more sample I will take. One, two, three, four, five. Right? Now, I can give the values also here. Let's give some values, 2 to 4. 5. Now, what is the width of this signal and what is the width of this signal? Here, if you want the width of the signal x of t is nothing but the difference of these two values. 4 minus 2, which is nothing but 2 units. 2 units. Here, width of the signal x of n. X of n is nothing but, here width means the number of samples here. Discrete time signal width means number of samples. How many samples are you are going to have? 1, 2, 3, 4, 5. Right? And that can be obtained upper limit minus lower limit plus 1. Upper limit minus lower limit plus 1 here. This 5 minus 1 plus 1, which is nothing but 5 units. 5 units. Suppose if this has the values like this, T1 to T2, so width of the signal x of t is nothing but T2 minus T1. T2 minus T1. Now width of the signal x of n, suppose if this is n1, this is n2. So here width of the signal x of n becomes n2 minus n1 plus 1. Try to remember this one. So in discrete, width is not n2 minus n1, but it is n2 minus n1 plus 1 you have to take. n2 minus n1 plus 1, whereas in continuous, t2 minus t1. Very, very important concept. Right? Here the discrete time signal width means number of samples. How many samples we are having? 1, 2, 3, 4, 5. 5 samples we are having. So this is nothing but the width. How to get that one? 5 minus 1 plus 1. So n2 minus n1 plus 1. Right? So this is the width of continuous time signal. Continuous time signal width means T2 minus T1 only. Try to remember. So these are the basics required. And now we'll do one thing. Let's switch to the next topic called, we'll see the basic signals or standard signals, which plays a crucial role in our subject. and we are going to discuss all the basic signals what we are going to encounter in the subject. As discussed earlier, the next topic what we are going to discuss is an important topic in the subject, which is nothing but basic signals or standard signals. You also put the subheading along with me. Basic signals are standard signals. We are going to discuss all the basic signals what we are having in our subject. Basic signals are standard signals. What is the first signal you are going to discuss? The first and foremost signal is continuous time unit step. Continuous time unit step signal. Unit step signal. What is the definition of this signal? How you are going to define the signal? And what are the characteristics of this signal? What are the characteristics of this signal we are going to discuss now. Now, continuous time unit step signal is denoted by UT, and is defined as 1 for t greater than 0 and 0 for t less than 0. What is the shape of this signal? This signal can be shown like this. This is what is your continuous time unit step signal. So you have defined this signal as 1 for t greater than 0 and 0 for t less than 0. Then what about t is equal to 0, sir? Means take a note. Important point. Take a note. Note. What we are going to write in this note? That the signal u of t is discontinuous at t is equal to 0. What is the nature of the signal? The signal is discontinuous at t is equal to 0. And from basic mathematical knowledge, what is continuity? Continuity means at a point left hand limit must be equal to right hand limit. Suppose if I take this point 0, for a small value less than 0, what is the value of the signal? 0. And for a small value greater than 0, what is the value of the signal? 1. Means at 0, left hand limit is not equal to right hand limit. So we say that this signal is discontinuous at t is equal to 0. And remember one important point, that in our subject signals, sudden rise is termed as discontinuity. Sudden rise or sudden fall. Whenever you are going to have sudden rise or sudden fall in the signal, at that point left hand limit will not be equal to right hand limit and the signal becomes discontinuous. So let me write that point. So discontinuity means sudden rise, sudden rise or sudden fall in the signal. Sudden fall in the signal is termed as what? Discontinuity. Discontinuity. And one more important point is that, remember, a discontinuity value of the signal is not defined. A discontinuity value of the signal is not defined. Means we can say that u of 0 is not defined. But for mathematical purpose, we cannot say that u of 0 is not defined. But we must have some value. So whenever you get any discontinuity like this, that is sudden rise or sudden fall in the signal, and if you want to have the value at the point of discontinuity according to Gibbs phenomena, what you have to do is simply take the average of the values. Simply take the average of the values so that your u of 0 is taken to be average of 0 and 1. 0 plus 1 by 2, which is nothing but 1 by 2. So this is the value of u of 0. U of 0 is taken to be 1 by 2 mathematically. Or you can modify the definition of u of t like this. U of t, observe here, 1 for t greater than 0, 1 by 2 at t is equal to 0 and 0 for t less than 0. 0 for t less than 0. This is a modified definition of the unit step signal u of t. Remember, the signal u of t is discontinuous at t is equal to 0. Discontinuity means sudden rise or sudden fall in the signal is termed as discontinuity. After this, we'll try to perform the transformations of the independent variable on this unit step and we'll observe. Okay, so for that I'm going to the next slide. Now, first transformation, and before going to the transformations of the independent variable for unit step, I want to say one point that you can note also in unit step signal coefficient. In unit step signal, coefficient indicates the amplitude. In unit step signal, coefficient represents the amplitude or value. Amplitude or value. For example, if I say that x of t is equal to 2u of t. If I say x of t is equal to 2u of t. Here, what is the coefficient? 2. So, this is a unit step signal starting at t is equal to 0. Starting at t is equal to 0 and going with the amplitude of 2. Suppose if I write x of t is equal to minus 10u of t. This is also a unit step signal starting at u of t means starting at t is equal to 0 going with a amplitude or value of minus 10. This is the shape of the signal. Hope you understood this one. Remember, in unit step signal, coefficient represents the amplitude or value. Now, let's perform some transformations of the independent variable. So, time shifting. So, what happens if I perform time shifting on the unit step signal? So, time shifting. Let me put the heading. Time shifting operation on the unit step signal. Say, if I ask you to draw two signals. First one is x of t is equal to u of t minus 1. Second one is x of t is equal to u of t plus 1. These two signals, if I ask you to draw. Now, this is in the form of x of t minus t naught, where the value of t naught is, or this is in the form of u of t minus t naught, where the value of t naught is 1, positive. Time shifted version t naught positive means what? Delayed version, advanced version, delayed version. Delay means right shift or left shift? Right shift. So, simply shift right the given signal by 1 minute. This is what is your u of t minus 1. And it will be going with a value or amplitude of coefficient represents the amplitude not 1. Nothing is there means by default 1. In the same way, in order to get u of t plus 1, compare with the standard shift. This is in the form of u of t minus t naught, where the value of t naught is minus 1. Positive or negative? Negative. Time shifting operation t naught negative means what? Delayed version, advanced version. Advanced version. Advanced version means left shift. So, simply shift left the given signal by 1 minute. This is u of t plus 1. So that you are able to achieve the time shifting operation successfully. Suppose 2u of t plus 10 if I ask you. 2u of t plus 10. So, u of t plus 10 means what? It is a step signal starting advanced by minus 10 units, right? Now, advanced by 10 units, going with a value or amplitude of 2. So, this is 2u of t plus 10. Hope you are all comfortable with the first transformations of the independent variable time shifting for our unit step signal. right? Now let's perform time reversal. Time reversal, and we'll observe what will happen. So time reversal operation for unit step signal. If I go for this, say I'm having the unit step signal u of t, from which I am asked to get u of minus t. U of minus t. So we know that time reverse version is nothing but mirror image along vertical axis or folding the signal along vertical axis. U of t is there with us like this. This is u of t. Now u of minus t means what? Time reverse version. Mirror image along vertical axis or simply fold the signal along vertical axis or just flip the signal along vertical axis. So that I am going to get this one. This is u of minus t. Now can you get minus u of minus t? Yes, we can get. Minus u of minus t means what? To this time reverse version, take the mirror image along horizontal axis. This is what is here? Minus u of minus t. Right? Now, from this time reverse version, we can get one important information that what happens if I add these two? U of t plus u of minus t. What happens if I add? For t greater than 0, okay, if I add, what will happen? For t greater than 0, this value is 1, this value is 0. 1 plus 0, 1. For t less than 0, this value is 0, this value is 1. 0 plus 1, 1. So that the resulting signal will be like this. At t is equal to 0, if you consider this is 1 by 2, discontinuity, take the average of the values. Discontinuity is there, so sudden fall is there, take the average of the values. So 1 by 2 plus 1 by 2, 1. So this is the resulting signal. So this is nothing but the constant signal or DC signal 1. Remember, if I try to add u of t and u of minus t, I am going to get the DC signal 1. Very, very important result. To be remembered. To be remembered. U of t plus u of minus t is a constant signal or a DC signal 1. Right? Now, after this is about time reversal operation. Let's switch to the next transformation of the independent variable. What is that? Time scaling operation. Right? Time scaling operation. For that, I am going to take a new slide. So, time scaling, let me put the heading. Time scaling. Scaling means what? Do you remember? Multiplying the independent variable by a constant is known as time scaling. Right. Now, if I try to perform time scaling, so one example I'll take u of t. From u of t, you try to get what is u of 2t. From u of t, you try to get u of 2t. Now, u of t is there with me. Okay, this is my continuous time unit step signal, which is discontinuous at t is equal to 0. Now, u of 2t if I want, what I have to do, what I told you, divide each point on the horizontal axis with the scaling factor. Divide each point on the horizontal axis with the scaling factor. What is the scaling factor here? 2, no? 2. So, divide each point on the horizontal axis with the scaling factor 2. What will happen? You will get the same signal u of t. You get the same signal u of t. Or, we can say that u of 2t is nothing but u of t. U of 2t is nothing but u of t, or in general, I can generalize this as u of alpha t. This is important. U of alpha t is nothing but u of t. Remember, my dear students, u of alpha t is nothing but u of t. Now, some more analysis can be made from this expression. What is that? First of all, let me put this one in a box. After that, I'll make the analysis. U of alpha t is u of t. After this, look here. What happens if I replace, look here, what happens if I replace this t with t plus or minus t naught? What happens if I replace this t with t plus or minus t naught on both sides? So if I replace here, means I have to replace here also. T t plus or minus t naught. What does this mean? This means that suppose if you have a unit step signal consisting of transformation like this, simply you can ignore or neglect the scaling factor alpha. You can simply ignore or neglect the scaling factor alpha. Now we'll do one thing, whether this is working or not. See, whenever you have this kind of transformation here, these two are equal means what? I can neglect the scaling factor alpha. We'll see. Observe here, my dear students. For example, look here. U of 2t plus 1 I want to plot. Now, for that what we have to do? U of take 2 times 2 common, t plus 1 by 2. Now, this came to our form now. Now, neglect the value of alpha. So, this must be equal to U of t plus 1 by 2 if I neglect. So, I mean to say that U of 2t plus 1 is same as U of t plus 1 by 2. Sir, how can you say? Array, draw and verify. Let's verify. Always, whenever you are learning any subject, we have to experiment. Now, let's draw U of 2t plus 1 and we'll draw U of t plus 1 by 2 and we'll verify whether both are same or not. Now, how you are going to draw this one U of 2t plus 1? First shift, then scale, or first scale, then shift by taking alpha as common. Our procedures are there, no? So, how you are going to proceed? U of t is there with you. First shift, then scale, I am applying. U of t plus 1, first shift, then scale. Scaling by 2 units. U of 2t plus 1. Now, try to plot this one. U of t is there with you. U of t plus 1. U of t plus 1 means advanced version of U of t by 1 unit. Now, this is y of t. For this y of t, you have to scale this by 2 units. Means you divide each point on the horizontal axis with the scaling factor 2. What happens if I divide? Minus 1 will become minus 1 by 2. We go like this, right? But this is nothing but our U of t plus 1 by 2 only. Isn't it? U of t plus 1 by 2. So, U of 2t plus 1 is same as U of t plus 1 by 2. So, whenever you have this kind of transformation, so you put in this form and neglect that scaling factor. That is the advantage. Very useful in simplifying the problems. Hope you understood this one. After this, okay, let's go to the previous slide. Some more analysis is there. So, what is that we found out? U of alpha t is nothing but U of t. Here, from this here, what I am going to do is replace t with minus t here. What happens? Okay, what happens if I replace t with minus t? U of minus alpha t is nothing but U of minus t. Let's keep that one in also a box. U of minus alpha t is U of minus t. After getting this one, look here. Suppose if I ask this one U of minus 2t, U of minus 2t is nothing but, as for this one, U of minus t. You can verify. And here, what happens if I replace this t with t plus or minus t naught, as we did here? So here, U of minus of alpha into t plus or minus t naught is nothing but, both sides you have to replace, t plus or minus t naught. Means you can neglect the scaling factor if your unit step has this kind of transformation. You can neglect the scaling factor. Scaling factor only, not this minus sign. Remember, only scaling factor. With an example, we'll see. Don't worry, with an example, we'll see. So, let's go to the next slide. Now, what I want to have is U of minus 2t plus 1. U of minus 2t plus 1. So, first of all, if you make preliminary analysis, how I can write this one? U of minus 2 times t minus 1 by 2. So, I can neglect this 2, no? So, this becomes U of minus t plus 1 by 2. Minus t plus 1 by 2 if I neglect the scaling factor 2 here. So, U of minus 2t plus 1 is nothing but U of minus t plus 1 by 2. Let's see whether they are equal or not. So, how to verify? Use first shift then scale. So, u of minus 2t plus 1, no? So how to proceed? Start with u of t. First shift, go to u of t plus 1. Call this as y of t. Scale this y of t by minus 2 units to get u of minus 2t plus 1. So u of t is there with you. The original signal, u of t is there with you. U of t plus 1. Advanced version. This is y of t. You scale this y of t by minus 2. What will happen? This will go to minus, divide each point on the horizontal axis with a scaling factor. So observe here, from y of t you have to go to y of minus 2t, means reversal is there, scaling is there. You can take the order in which you like, or you can take all at a time also. Reversal and scaling you can take at a time also. So this becomes, if I scale, it will come 1 by 2. If I reverse, reversal will become like this. This is a signal. Now this is nothing but u of minus t plus 1 by 2 only. This signal is nothing but u of minus t plus 1 by 2 only. If you have any doubts, you try to apply first shift then scale for this one. You will get this one only, right? U of minus t plus 1 by 2. So in this way you can simplify the transformations of the independent variable. Fine. After this, we'll try to examine. See, time shifting is done, time reversal is done, time scaling is also done. After this, we'll try to solve some problems. Right? Now, if you have any doubt, if you have any doubt, sir, how I got this as u of minus t plus 1 by 2 means, observe. The previous IES question is there. He was asking like this. IES question. What is that question? What is the mathematical representation? A previous IES question he gave like. What is the mathematical representation of this signal x of t in terms of unit steps, he said. What is the mathematical representation of the signal x of t in terms of unit steps? Or we have to represent the signal x of t in terms of unit steps. How you are going to do? See, whenever we have this kind of signal, two things come to our mind. That the signal could be u of minus t plus 2, or the signal could be u of minus t minus 2. Right? Now we'll do one thing. As we know the tools, let's examine both. So if I take the second one, use first shift then scale. U of t is there with you. First shift the signal. Call this as y of t. Scale this y of t by minus 1, so that you will get u of minus t minus 2. U of t is there with us. U of t minus 2. U of t minus 2 means delayed version. Delayed version. Now this is y of t. Y of minus t means take the reversal, mirror image along vertical axis. Now if you observe, this is not the answer. So this, the first one might be the answer. Let's verify. First shift then scale. U of t is there with you. Go to u of t plus 2. Call this as y of t. Scale this y of t by minus 1, so that you will get u of minus t plus 2. Right? So u of t is there with us. Patience is required. U of t plus 2 means advanced version. This is y of t. For this y of t, you have to calculate y of minus t means take the mirror image along horizontal axis. Yes, this is that. Here, answer is not important, but how you are going to analyze the signal is important. Always remember, a unit step signal existing from minus infinite to 2 is u of minus t plus 2. U of minus t plus 2. A unit step signal existing from minus infinite to 1, u of minus t plus 1. A unit step signal existing from, if I ask you, minus infinite to 1 by 2. So this is nothing but u of minus t plus 1 by 2, which we got in the previous case. So in this way you can verify, right? So this was the previous IES question. So the answer is what? U of minus t plus 2. Right. After analyzing this signal, let's go to the next problem. Look here. Now, sometimes what happens, they'll give some expressions in terms of unit steps and they'll ask you to draw the shape of the signal. So, one such expression is given like this. Draw the signal. Draw x of t is equal to some u of t plus 1 minus u of t minus 1. Draw the signal x of t is equal to u of t plus 1 minus u of t minus 1. How we are going to draw? What do you know? U of t plus 1. First of all, analyze u of t plus 1. U of t plus 1 is a step signal. Starting at u of t plus 1 means advanced version of starting at minus 1, going with a value of where you will get the value or amplitude coefficient. Coefficient is 1. No? So u of t plus 1 is a step signal. First of all, that is a confirmation. Starting point. Starting at minus 1. I am analyzing this one. Starting at minus 1, going with a value or amplitude. Going with a value or amplitude of 1. Analysis for the first signal is completed. Now, u of t minus 1. U of t minus 1 is what? Is a step signal starting at SP means starting point. Starting at u of t minus 1, u of t minus 1 means delayed version. Starting at 1, going with a value or amplitude of minus 1. Right? Now let's draw the signal. What is the shape you are going to get here? This is your signal x of t. So let me use the other color. U of t plus 1 is a step signal starting at minus 1, going with a value of 1. So first of all, sudden rise will come here. Sudden rise will come because I am dealing with unit step. Now this will be going with a value of 1. As this is going with a value of 1, as the signal is going with a value of 1, when it encountered the point 1, one more value is added to this one. What is the value added? Minus 1. What happens if I add 1 to minus 1? The resulting value will become 0. So this is the shape of the signal. Done. Completed. You see how easy it is to draw the signal. So let's take one more example to get the confidence. Suppose if I give you this signal, x of t is equal to, observe, listen carefully, u of t plus 2 plus u of t plus 1, u of t plus 2 plus u of t plus 1 minus u of t minus 1 minus u of t minus 2. Right? Now let's draw the signal. How to draw? First of all, make analysis. U of t plus 2 is a step signal starting at what? U of t plus 2 is minus 2, going with a value of 1. Coefficient represents the value. No? Now, u of t plus 1. U of t plus 1 is a step signal starting at minus 1, going with a value of 1. Third signal. Minus u of t minus minus 1 is a step signal starting at 1, going with a value of minus 1. And minus u of t minus 2 is a step signal again starting at 2, going with a value of minus 1. Right? Now let's draw. I am drawing here. This is the resulting signal x of t. Right? Now observe here. U of t plus 2 is a step signal starting at what point? Minus 2, going with a value of 1. Starting at minus 2, going with a value of 1. So going with a value of 1. As this is going with a value of 1, when it encountered, look at, as the signal is going with a value of 1, when it encountered the point minus 1, what happened? One more value is added. what value is added? Value of 1 is added. Now this is coming with a value of 1. If you add one more value 1, what happens? The value will become 1 plus 1, 2. So it will become 2. Now this is going with a value of 2. This is 1. This will be going with a value of 2. As this is going with a value of 2, now the resulting signal is going with a value of 2. When it encountered the point 1, when it encountered the point 1, a value of minus 1 is added. What happens if you add a value of 2 to value of minus 1? Resulting value will become 1. So at 1 there will be a sudden decrease. Now this will be going with a value of 1. As this is going with a value of 1, when it encountered the point 2, what happened? A value of minus 1 is added. What happens if you add a value of 1 to value of minus 1? It becomes 0. So that the resulting signal can be shown like this. One more time I will repeat. U of t plus 2 is a step signal starting at minus 2 going with a value of 1. Starting at minus 2 going with a value of 1. As this is going with a value of 1, when it encountered minus 1, one more value is added. What happens if you add a value of 1 to 1? Resulting value will become 2. Now this is going with a value of 2. As this is going with a value of 2, when it encountered the point 1, value of minus 1 is added. Now this is going with a value of 2, value of minus 1 is added. So resulting value will become 1 at 1. Now this is going with a value of 1. As this is going with a value of 1, when it encountered the point 2, value of minus 1 is added. So resulting value will become 0. And remember, whenever you are having this kind of finite duration signal, these two are finite duration signals. No, already we have seen that these kind of signals are known as finite duration signals, which exist only for a finite duration. And if you are going to write in terms of unit steps, and if you add all the coefficients, it must result in 0. Observe, add coefficient 1, 1 plus 1, 2, 2 minus 1, 1, 1 minus 1, 0. Here, 1 minus 1, 0. So for this kind of finite duration signals, if you add all the coefficients, it must result in 0. One more, let's see, more number of problems. We must get the perfection right. Now I want you people to write this signal in terms of unit steps. Zero, 1, 2. I want this signal to be written in terms of unit steps. How you are going to write? Or not this problem. Let's modify the. I'm giving the answer. X of t is equal to u of t minus 2u of t minus 1 plus u of t minus 2. U of t minus 2 u of t minus 1 plus u of t minus 2 u of t minus 2 u of t minus 1 plus u of t minus 2. Now I want you people to draw this one. First of all, make analysis. U of t means what? Starting point is 0, value is 1. Minus u of t minus 2 u of t minus 1. Starting point is 1, value is minus 2. U of t minus 2. U of t minus 2 means starting point is 2, value is 1. Let's draw the signal. 0, 1, 2, 3. Observe here. U of t is a step signal starting at 0, going with a value of 1. Going with a value of 1. As this is going with a value of 1, when it encountered the point 1, one more value is added. What value is added? Minus 2. So this is going with a value of 1, a value of minus 2 is added. Resulting value will become minus 1. Resulting value will become minus 1. So now this will be going with a value of minus 1. As this is going with a value of minus 1, when it encountered the point 2, a value of plus 1 is added. What happens if I add a value of minus 1 to value of plus 1? Resulting value will become 0. In this way, you can draw the shape of the signal. You see how simple is it to draw the signal, right? Now, after this, I want to increase the complexity like this. I want the shape of the signal x of t is equal to u of sine t. I want the shape of the signal x of t is equal to u of sine t. How we are going to draw the signal? Try to analyze. Observe here. Very simple. In order to draw the signal u of sine t, first of all, you must be familiar with the definition of u of t. What is the definition of u of t? U of t is 1 for t greater than 0 and 0 for t less than 0, so that u of t can be shown like this. Right? In the same way, can you define u of sine t? Yes, I can define. How? U of sine t is nothing but 1. In the place of t, I have sine t. So, if sine t greater than 0 and 0 if sine t is less than 0. Right? Now, we'll try to draw first of all sine t. What is the shape of sine t? Do you remember? This is what is your sine t. Sine t. Right? So, what is the maximum value? 1. What is the minimum value here? -1. This is +1. This is -1. Observe here. So, what are these points, my dear students? What are these points? Sin t becomes 0 at plus or minus n pi now. So, this is 0. This is pi. This is 2 pi. This is minus pi. This is minus 2 pi and so on. This is 3 pi. Now, u of sin t I want. U of sin t is, look here, 1 if sin t greater than 0 and 0 if sin t less than 0. Oh, very simple. Look here. First of all, project these values. Project these values. Complete analysis on unit step signal. This is minus pi, this is minus 2 pi. Observe here. So let me use which color? Red color. Okay. So u of sin t is 1 if sin t greater than 0 and 0 for sin t less than 0. 0 to pi, if you observe, 0 to pi, this portion, sin t is greater than 0, no? 0 from 0 to pi. So what is the value of u of sin t? U of sin t will take the value 1. U of sin t will take the value 1. Now pi to 2 pi, sin t is less than 0. So u of sin t will be 0. U of sin t will be 0. Again from 2 pi to 3 pi, 2 pi to 3 pi, sin t, this one is sin t, no? This one is sin t, this is u of sin t. From 2 pi to 3 pi, sin t is greater than 0, so u of sin t will be 1. And so on, it will repeat. Here, from minus pi to 0, sin t is less than 0, so u of sin t will be 0. Again, from minus 2 pi to minus pi, sin t is greater than 0. Sin t is greater than 0 means u of sin t is 1. And it will repeat like this. So this is the shape of u of sin t. Hope you are all comfortable with this one. Your homework is draw u of cos t. Draw u of cos t. U of sin t, I have shown you how to draw. Now you have to draw u of cos t. After this, let me give you one more question. I want, okay, this is this color only. I want the shape of the signal. Draw u of 1 minus mod t. So yes, draw the signal x of t is equal to u of 1 minus mod t. Now how you are going to draw? For this, again, u of t is 1 if t greater than 0 and 0 if t less than 0. So that u of t is given like this. Right. Now I want the shape of u of 1 minus mod t. How can you define? U of 1 minus mod t is 1 if 1 minus mod t greater than 0 and it is 0 if 1 minus mod t is less than 0. Or still I can further simplify this as u of 1 minus mod t is equal to 1 minus mod t greater than 0 or 1 greater than mod t or mod t less than 1. Can I write like this? 1 greater than mod t, 1 greater than mod t or mod t less than 1, and it is 0. 1 less than mod t, 0 for 1 less than mod t or mod t greater than 1. See, mod t less than 1, mod means what? Plus or minus t, less than 1 means what? Minus t less than 1 to t less than 1. Minus t less than 1 means t greater than minus 1 to t less than 1. So these are the limits. Always remember, mod t less than 1 means these are the limits. Now the signal is existing from what value to what value? Minus 1 to 1, of which what is the signal? It is 1. Signal value is 1. So this kind of signal here. This is u of 1 minus mod t. This is the expression, this is the shape, right? Fine. After this, now I'm pretty much confident, or before going to the next part, if I ask you one question, that the value of u of minus 2t plus 4 minus u of minus 2t plus 2 at t is equal to 3 is, if I ask you this question, u of minus 2t plus 4 minus u of minus 2t, I'll do one thing, minus 2t minus 2, minus 2t minus 2 at t is equal to 3 is, what is the value? Can you calculate? Come on, try to solve this one. Take 30 seconds time. Yes, observe here. U of minus 2t plus 4. U of minus 2t plus 4. How I can write this one? Can I write this as u of, take minus common, t minus 2. T minus 2. And already we have seen that whenever you have this kind of transformation, you can neglect the scaling factor, so that this is nothing but u of minus t plus 2. U of minus t plus 2, and from the previous IES analysis, we have seen that u of minus t plus 2 is a unit step signal existing from what value to what value? Minus infinite to plus 2. This is the shape. U of minus 2t minus 2. Come on, how I can write this one? This is u of minus 2, take common. See, for one single signal unit step, how much analysis we are going to make. Neglect this 2 here. This is u of minus t minus 1. Right? U of minus t minus 1 means it is a step signal existing from what value to what value? Minus infinite to minus 1. Now, what is the operation involved between these two? Subtraction. The top signal, because the top signal is existing from what value to what value? Minus infinite to plus 2. Whereas the bottom signal is existing from minus infinite to minus 1. Now, what happens if I subtract the bottom signal from the top signal? Simple subtraction. What is that I am going to get? Come on. From minus infinite to minus 1, okay, from minus infinite to minus 1, the value of the top signal is 1, the value of the bottom signal is also 1, so the resultant is 0. Now from minus 1 to, okay, from minus 1 to 2, the value of the top signal is 1, whereas the value of the bottom signal is 0. So 1 minus 0 is 1. So the resulting signal will exist from minus 1 to 2 with a value of 1. The value of 1. Now, at what point he is asking us to calculate at t is equal to 3? The value of the signal x of t at t is equal to 3. What is this value? It is 0. In this way, we are going to solve this problem. Hope you enjoyed this problem. The next part is, look here. Now we are in a position that, given the expression, we are in a position to draw the signal. The converse must be true. Means, given the signal, we must be in a position to frame the expression also. Given the signal, we must be in a position to frame the expression. That also will see. Okay. First problem. Suppose simple with a simple one I am starting. Suppose we are given this one. The question is, express this signal in terms of unit steps. Let me write the question. Express x of t in terms of unit step signals. Come on, try to solve this. How to solve this one? Or how to write the expression? Look here, always remember, always look from the left. At minus 1, there is a sudden rise. Always, whenever we are going to have a sudden rise, start with u of t. So here, minus 1, we are having a sudden rise means start with unit step signal. Now that is going with a value of what? 1. So unit step signal starting at minus 1, going with a value of 1. Unit step signal starting at minus 1, going with a value of 1. What could be that signal? What could be that signal? U of t plus 1. U of t plus 1 is a step signal starting at minus 1, going with a value of 1. As this is going with a value of 1, when it encountered, listen carefully, u of t plus 1 is a step signal starting at minus 1, going with a value or amplitude of 1. As this is going with a value of 1, when it encountered 1, its value became 0. Its value became 0. So what value must be added to this value 1 to make it a value of 0? What value must be added to 1 to make it a value of 0? A value of minus 1 must be added. At what point it must be added? It must be added at 1. So what is that step signal? What is that step signal? Going with a value of minus 1, starting at t is equal to 1. Going with a value of minus 1, starting at t is equal to 1. That's simple as that. X of t is u of t plus 1 minus u of t. Okay. Hope you are all comfortable. Don't worry. If you look at 2 or 3 examples, you'll get the confidence. Now, okay. Let me look at the next one. Zero, 1, 2, 3. Say like this. this value is 10. Let's assume this value is 10. This is x of t. At 2, so this value became 5. Try to express this signal in terms of unit steps. Try to express this signal in terms of unit steps. Can you express this signal in terms of unit steps? Yes. Look at how. Starting from the left, I came to point 1. At 1, what is the nature of the signal? Sudden rise. Sudden rise is there. So start with u of t. And with what value it is going? Sudden rise at 1, it is going with a value of 10. It is going with a value of 10. So observe here. So x of t, my x of t will become like this. Starting at 1, going with a value of 10 means 10 u of t minus 1. 10 u of t minus 1 is a step signal. Step signal starting at 1, going with a value of 10. As this is going with a value of 10, observe here. When it encountered the point 2, its value became 5. So what value must be added to 10 to make it a value of 5? What value must be added to 10 to make it a value of 5? A value of minus 5. Value of minus 5 must be added. At what point? 2. Value of minus 5 at the point 2 means what? Value of minus 5 coefficient starting at 2. U of t minus 2. Now if I add this signal and this signal, the resulting signal will be going with a value of 5. As this is going with a value of 5, when it encountered the point 3, its value became 0. Now what value must be added to 5 to make it a value of 0? A value of minus 5 must be added. At what point? 3. Value minus 5 starting at t is equal to 3 means what? Minus 5 u of t minus 3. And this is a finite duration signal. If you add all the coefficients, it must result in 0. 10 minus 5, 5 minus 5, 0. Here also 1 minus 1 is 0. So in this way you are going to write the expression for this signal. Don't worry, we look at 2 or 3 more examples so that you get confidence. Right? After this is done, let me take the next question. I'll take like this. You have to solve more number of questions, then only you will get confidence. Yes, this kind of signal I am having. Minus 3, minus 2, minus 1, 0, 1, 2, 3. From here to here, from here to here, from here to here. This is 3. Right. We have to express this signal in terms of unit steps. How we are going to write? Starting from the left. Observe. At minus 3 there is a sudden rise. Start with u of t at minus 3. With what value it is going? It is going with a value of 1. So u of t plus 3, no? U of t plus 3 is a step signal starting at minus 3 going with a value of 1. As this is going with a value of 1, when it encountered minus 2, its value suddenly became 2. So what value? This is coming with a value of 1, no? Now what value must be added to this u of t plus 3 to make it a value of 2? This is coming with a value of 1. What value must be added? A value of plus 1 must be added so that its value will become 2. So value 1. At what point it must be added? Minus 2. So u of t plus 2. Now if I add these two signals, what will happen? The resulting signal is going with a value of 2. As this is going with a value of 2, if you observe the signal, at minus 1 its value suddenly became 3. So what value must be added to 2 to make it a value of 3? A value of 1 must be added. At what point it must be added? Minus 1. So value 1 starting at t is equal to minus 1 means u of t plus 1. U of t plus 1. Now, the resulting signal is going with a value of 3. As this is going with a value of 3, when it encountered 1, its value became 2. So, what value must be added to 3 to make it a value of 2? A value of minus 1 must be added. At what point? 1. So, value of minus 1 means coefficient starting at t is equal to 1. Now, what happened? The resulting signal now is going with a value of 2. As this is going with a value of 2, when it encountered the point 2, its value became 1. So, what value must be added to 2 to make it a value of 1? A value of minus 1 must be added. At what point? 2. Value of minus 1 at the point 2. Now, the resulting signal is going with a value of 1. Now, what value must be? Now, if you observe at 3, the total value became 0. Now, what value must be added to 1 to make it a value of 0? The value of minus 1. At what point? In this way, you are going to write the signal in terms of unit steps. Add all the coefficients 1, 3, 2, 1, 3. Yes, one more. Can you write this signal in terms of the unit step signals? Can you write this signal in terms of unit step signals is the question. The first part, how can you write? Observing from the left, 0 sudden rise means u of t. So, value is 1. As this is going with a value of 1, when you encountered the point A, its value became 0. So, what value must be added to 1 to make it a value of 0? A value of minus 1 must be added. At what point? At the point A. Value minus 1 starting at t is equal to A means minus u of t minus 1. So, we got this part. Completed. This part is completed. U of t minus u of t minus A. U of t minus u of t minus A is this part. Now, come here. Come to this part. U of here at 2a we have a sudden rise. At 2a we have a sudden rise. So, u of t minus 2a and is going with a value of 1. Okay. But at 3a its value became 0. Means subtract the value 1. T minus 3. So that analysis of this part is completed. Right. Now, here at 4a we have sudden rise. With a value, you have to observe the value. Value is 1 now. So, u of t minus 4a. At 5a it became 0. And as the signal is repeating, this will also repeat. So, the analysis of this part is also complete. In this way, we are going to analyze different signals using unit steps. First part, second part, third part. From this, he may ask you to calculate anything, calculate the Laplace transform of this signal. And some quantities he will ask you to find out. Right. So, we'll do one thing. This is regarding the first basic signal called unit step signal. In the next discussion, we are going to have some more basic signals, and I hope you enjoyed this session. Thank you.